Okay, we're looking at the first problem here that was from a previous test. The question asks to simplify and state any restrictions. So we're going to tease apart this, what do we have here? Three fractions, three rational expressions, by factoring both numerator and denominator of each fraction one at a time. So let's zoom in here, and we're going to take a look at the first one. Notice here that we have a simple trinomial here at the top. We have a complex one here at the bottom. As far as I can tell, we can't really factor anything out of this one here. So I'm just going to go ahead and start factoring both of these. So my numerator for the first one, that's this guy up here. I'm looking for two numbers. They add to give me 10, multiply to give me 24. That's pretty simple. The numbers are 6 and 4. So I'm just going to rewrite this as x plus 6 and x plus 4. Notice how I didn't bother carrying out the x method or the decomposition. I'm assuming that at this stage, you kind of have a handle on factoring simple trinomials of this sort. This guy here, I'll be a bit more explicit. I will use my x method. And I'm looking for two numbers that add to give me 16 and they multiply to give me negative 36. Those numbers are, let's see, 9 and 4 give me 36, negative 18, positive 18 and negative 2. Both of those add to give you 16, multiply to give us negative 36. We're going to multiply both of those by 3, which is the coefficient in front of the x squared. This reduces to 6 over 1. This will just remain negative 2 over 3. And we can factor this out as 3x minus 2 and x plus 6. So that's our first term. Let's move on to our second. And we're going to have to just move some of this stuff out of the way. So I'll put this here. This is just pointing to the work to factor that term. And now let's look at the second one. So a multiplication here. Drawing our fraction line. This numerator, almost looking like a difference of squares. We have an x squared here, a minus 9, which is 3 squared, but that x is not squared. So we can't exactly treat this as a difference of square. But notice that we can common factor an x out of the two terms. So I'm going to bring an x out in front. I'm going to get x minus 9. And the bottom looks like we can factor out a 3x squared. Again, the highest exponent that divides both terms. And this leaves us with 3x and then plus 2. And finally, we have our last term. And it is a division. So before we take the reciprocal, we're just going to factor this numerator up here. And what do we get? Two numbers that add to give us negative 5, multiply to give us negative 36. The numbers are x minus 9, so negative 9 and positive 4. Those work. And in the denominator here, it looks like actually we do have a difference of squares, because this can be rewritten as, if I take this guy here, this is just 3x squared minus 2 squared. And I apply my difference of square pattern to get 3x minus 2 and 3x plus 2. Okay, so we factored out our expression here, all the terms in it. And what I want to do next is just identify any restrictions, because I do believe, yeah, it says state any restrictions. So I'm going to have to look at all these denominators one at a time. So let's look at this guy here first. What will make that term 0? In other words, what value of x will make that equal 0? Well, you just solve it like a grade 9 linear equation. I get 3x equals 2, x equals 2 over 3. So there's my first restriction for this guy. For the next one, well, that's pretty obvious. If x is negative 6, you'll get 0. So that's this guy here. This is for this one here. This factor, we have an x. Well, the only value of x that can make it 0 is 0 itself. And then we got this guy, same question, what value of x will make it equal to 0? And if we solve, we'll find that we get x equals negative 2 over 3. Again, very similar to this one, but negative. Moving over, this guy here, same as the first one. This one here, same as this one here, so we don't have to bother to repeat it. And it looks like we have 4 restrictions in this case. X cannot be equal to 0, negative 6, and plus minus 3 over 2. Again, the plus minus is, here's the positive case, here's the negative case. I combine them just to write succinctly into one as plus minus 3 over 2. Okay, now we are ready to do the fun stuff, which is cancel out common factors. And before I do that, I'm just going to copy this here, put a big circle around it, bring it down here, and let's see what we can start to cancel out. I'll do that in red. Just zoom in for a moment. So what do we have here? I have x plus 6, so this will cancel with this denominator. And that's it for these guys here. Now for the division, I can't cancel anything out in just that fraction alone. However, combined with this guy here, I can. However, I have to invert it first. I have to reciprocate this guy first. So what I'm going to do is take this numerator, move it out, swap it with my denominator, put it here, and instead of a division, we have a multiplication. And now let's see if we can continue our cancellation efforts. Because everything is being multiplied, we can go across fractions. So this will work. Anything else? Yeah, we got that 3 minus 2 and this 3 minus 2. We have this x plus 4. We have this x plus 4. We have this x minus 9. We have this x minus 9. And I'm going to just highlight what we're left with, which is this guy, and this one here. And in fact, we can go even further because x and x squared just reduces that down to 1. And it looks like our final answer is going to be 1 over 3x. So there is your first question with any restrictions stated.